The geological history of Earth follows the major geological events in Earth's past based on the
geological time scale, a system of chronological measurement based on the study of the planet's rock layers. Stratigraphy.
Earth formed about 4.54 billion years ago by accretion from the solar nebula.
A disk-shaped mass of dust and gas left over from the formation of the Sun, which also created the rest of the solar system.
Earth was initially molten due to extreme volcanism and frequent collisions with other bodies.
Eventually,
the outer layer of the planet cooled to form a solid crust when water began accumulating in the
atmosphere.
The Moon formed soon afterwards, possibly as a result of the impact of a planetoid with the Earth. Outgassing and volcanic activity produced the primordial atmosphere.
Condensing water vapor, augmented by ice delivered from comets, produced the oceans. However, more recently, in August 2020, researchers reported that sufficient water to fill the oceans may have always been on the Earth since the beginning of the planet's formation, as the surface continually reshaped itself over hundreds of millions of years.
Continents formed and broke apart.
They migrated across the surface, occasionally combining to form a supercontinent. Roughly 750 million years ago, the earliest known supercontinent Rodinia began to break apart. The continents later recombined to form Pannotia. 600 to 540 million years ago, then finally Pangaea, which broke apart 200 million years ago. The present pattern of ice ages began about 40 million years ago, then intensified at the end of the Pliocene. The polar regions have since undergone repeated cycles of glaciation and thaw, repeating every 40,000–100,000 years. The last glacial period of the current ice age ended about 10,000 years ago. The Precambrian includes approximately 90% of geologic time. It extends from 4.6 billion years ago to the beginning of the Cambrian period, about 541 Ma. It includes 3 eons, the Hadean, Archean, and Proterozoic. Major volcanic events altering the Earth's environment and causing extinctions may have occurred 10 times in the past 3 billion years.
During Hadean time,
4.6–4 Ga, the solar system was forming, probably within a large cloud of gas and dust around the Sun, called an accretion disk, from which Earth formed 4,500 million years ago. The Hadean eon is not formally recognized, but it essentially marks the era before we have adequate record of significant solid rocks.
The oldest dated zircons date from about 4,400 million years ago.
Earth was initially molten due to extreme volcanism and frequent collisions with other bodies. Eventually, the outer layer of the planet cooled to form a solid crust when water began accumulating in the atmosphere. The Moon formed soon afterwards, possibly as a result of the impact of a large planetoid with the Earth. Some of this object's mass merged with the Earth, significantly altering its internal composition, and a portion was ejected into space. Some of the material survived to form an orbiting Moon. More recent potassium isotopic studies suggest that the Moon was formed by a smaller, high-energy, high-angular momentum giant impact cleaving off a significant portion of the Earth. Outgassing and volcanic activity produced the primordial atmosphere.
Condensing water vapor, augmented by ice delivered from comets, produced the oceans. However,
more recently, in August 2020, researchers reported that sufficient water to fill the oceans may have always been on the Earth since the beginning of the planet's formation. During the Hadean, the late heavy bombardment occurred, approximately 4,100 to 3,800 million years ago, during which a large number of impact craters are believed to have formed on the Moon, and by inference on Earth, Mercury, Venus and Mars as well. The Earth of the early Archean, 4,000 to 2,500 million years ago, may have had a different tectonic style. During this time, the Earth's crust cooled enough that rocks and continental plates began to form. Some scientists think because the Earth was hotter, that plate tectonic activity was more vigorous than it is today, resulting in a much greater rate of recycling of crustal material. This may have prevented cratonization and continent formation until the mantle cooled and convection slowed down. Others argue that the subcontinental lithospheric mantle is too buoyant to subduct and that the lack of Archean rocks is a function of erosion and subsequent tectonic events. Some geologists view the sudden increase of aluminum content in zircons as an indicator of the
beginning of plate tectonics.
In contrast to the Proterozoic, Archean rocks are often heavily metamorphized deep-water sediments, such as grey-wax, mudstones, volcanic sediments and banded iron formations.
Greenstone Belts are typical Archean formations,
consisting of alternating high and low-grade metamorphic rocks. The high-grade rocks were derived from volcanic island arcs, while the low-grade metamorphic rocks represent deep-sea sediments eroded from the neighboring island rocks and deposited in a forearc basin. In short, greenstone belts represent sutured protocontinents. The Earth's magnetic field was established 3.5 billion years ago. The solar wind flux was about 100 times the value of the modern Sun. So the presence of the magnetic field helped prevent the planet's atmosphere from being stripped
away, which is what probably happened to the atmosphere of Mars.
However,
the field strength was lower than at present and the magnetosphere was about half the modern
radius.
The geologic record of the Proterozoic,
2,500 to 541 million years ago, is more complete than that for the preceding Archean. In contrast to the deep-water deposits of the Archean, the Proterozoic features many strata that were laid down in extensive shallow epicontinental seas. Furthermore, many of these rocks are less metamorphosed than Archean age ones, and plenty are unaltered. Study of these rocks show that the Eon featured massive, rapid continental accretion, unique to the Proterozoic, supercontinent cycles, and wholly modern orogenic activity.
Roughly 750 million years ago, the earliest known supercontinent Rodinia began to break apart. The continents later recombined to form Pannotia, 600 to 540 Ma. The first known glaciations occurred during the Proterozoic. One began shortly after the beginning of the Eon, while there were at least 4 during the Neoproterozoic, climaxing with the snowball Earth of the Varangian glaciation. The Phanerozoic Eon is the current eon in the geologic timescale. It covers roughly 541 million years. During this period, continents drifted about, eventually collected into a single landmass known as Pangaea and then split up into the current continental landmasses. The Phanerozoic is divided into 3 eras: the Paleozoic, the Mesozoic and the Cenozoic. Most of the evolution of multicellular life occurred during this time period.
The Paleozoic spanned from roughly 542 to 251 million years ago, Ma, and is subdivided into 6 geologic periods. From oldest to youngest they are the Cambrian, Ordovician, Silurian, Devonian, Carboniferous and Permian. Geologically, the Paleozoic starts shortly after the breakup of a supercontinent called Pannotia and at the end of a global ice age. Throughout the early Paleozoic, the Earth's landmass was broken up into a substantial number of relatively small continents. Toward the end of the era, the continents gathered together into a supercontinent called Pangaea, which included most of the Earth's land area. The Cambrian is a major division of the geologic timescale that begins about 541.0 plus or minus 1.0 Ma. Cambrian continents are thought to have resulted from the breakup of a Neoproterozoic supercontinent called Pannotia. The waters of the Cambrian period appear to have been widespread and shallow. Continental drift rates may have been anomalously high. Laurentia Baltica and Siberia remained independent continents following the breakup of the supercontinent of
Pannotia. Gondwana started to drift toward the South Pole.
Panthalassic covered most of the southern hemisphere. And minor oceans included the Proto-Tethys Ocean, Iapetus Ocean and Cantae Ocean.